So greeting and welcome student in our today's online section of subject Mediatronics. Today we are going to take another concept about chapter number 2, which is conversion of analog and digital signals. Also we will see the introduction of data acquisition system also in the same section. Okay, so here we are starting from this. What is analog and digital signal? So in the very first section of this subject I already explain you some part of this analog and digital signal. So what is analog signal? Analog signals are the continuous signals, whereas the digital signals are the discrete signals. The physical phenomenon are mostly in the analog format because they are continuously, but digital signals are the signals which are understood by means of the computer. So to provide some information to the computer, we need to provide it in the form of the digital. Okay, so a digital signal are used for the computer processing. So that's why we need to convert this analog signal to the digital signal so that it will be processed in the computer itself. Okay, listen me. In microphone, the sound waves from our voice are transmitted by the telephone in the form of the radio waves. When combined with digital signal, we can move data along the telephone lines. So while we are talking on the phone, your voice or your sound waves are the analog signals which are converted to the digital by means of the cell phones, and then these digital signals are sent over the telephonic lines or transport lines there, and the receiver or the person who is hearing you, on his device these digital signals are converted into the analog one and he then listen them. Okay, so an analog signal is a continuous and it is shown by a line. Here you can see this is the analog signal which is shown by a continuous line, and it can be vary in signal strength, means amplitude and the frequency. The wave amplitude value is higher and lower points of the wave, while the frequency times value is measured in the wave physical length from left to right in one cycle. The sound from a human voice is analog because the sound waves are continuous. Also light waves are analog. Now here we are digital signals. A digital signal used for a computer processing is denoted by using a binary 0 and 1s. You know, you all are very familiar that computer only understand the binary language which contains 0 and 1. For example, the analog wristwatch shows the time of a day with its minute, hour and sweeping second hands is replacing by a digital watch which offers the time of the day and other information using a numerical display. Digital signals are represented here on this diagram. You can see these lines here, not continuous one. This discrete line, the steps here, these are the steps. This is the digital signal, and this continuous line, it is the analog signal. This is the analog signal which is continuous, and these are the discrete steps or discrete lines here. This is the digital signal. Okay, so here we can see on this screen that digital to analog converter, DAC, and its application. So or what will be the need of analog to digital and digital to analog need of conversion. Here we are taking a simple example. Suppose we are having a singer which is singing on a mic. So what is happening here? The sound waves created by the singers are analog. When it goes over the mic converts this analog signal to the digital signal by means of the ADC, which is analog to digital converter. Here you can see these are the analog waves which are coming from the singer, and mic convert it into and this analog to digital converter convert it into the digital signal. Then this digital signals then these digital signals are transferred from this place of the mic to the speaker, and before it reaching the speaker we are again having here a converter which is digital to analog converter, DAC, and then these analog signals are sent to the speaker here, and in the speaker we again hear the sound which is the analog signals. So what is happening? To transmit the data from one place to another place, we need to convert this analog signal into the digital one, and again to digital to analog for its particular application. Here you can see that singer sings means here creating the sound waves which is analog signals. These analog signals are converted to digital one by converter ADC, and which are then transferred from this one place to another place, and before it reaching these speakers we again convert it into the analog signal by using this DAC converter here. Okay. So I hope you can understand the need of this conversion. Okay, so here we are going to see this analog to digital converter. Engineering signals are continuous, means they vary over a time. So engineering signals are continuous, such as voltage that varies over a time, or a chemical reaction rate that depends on temperature. So here you can see analog to digital converter and digital to analog converter allow digital computers to interact with this signal. So here this is the green wave you can see here, it is the analog signal, and here we are converting this analog signal to the digital signal by using the analog ADC, analog to digital converter. So here what is happening? Here we are breaking this continuous line over a sample times frame. We record this analog input, means analog signal or analog input at some specific time frames, and at that time we are taking this value of this amplitude of this analog signal and we plot it on this line here by converting the analog signal into the digital signal. Here you can see these lines are the time frames here. This time lines or time frame is common here in case of the analog and digital signal, and then we convert this amplitude of this analog signal and we plot this amplitude on the digital signals here, and then we get converted the analog signal into the digital signal. Here you can see when this analog signal amplitude of analog signal drops, we take this point very near to the ground line. When the amplitude means this line here, this amplitude of this analog signal as very high point, at that time we take this point at high from this ground line on the digital output. For this we are going to use the analog to digital converter. Here you can see while converting this analog to digital, so digital signals are the binary ones which are either in the format of 0 and 1. Here you can see this green line, it is the analog line, and when 1 bit analog to digital conversion is done, so we name this low amplitude value as 0 and high amplitude value as 1. Here for 2 bit analog to digital converter we are having this green line which is analog signal, and we are converting it into the digital one by this red line here. Okay, and between these two vertical lines we have the time frame or sample time. Okay, so for this 2-bit analog to digital conversion, we have this value as 00011011. Means here we are going to convert this analog signal to digital one or binary signal one. Similarly for this, here we are having this 3-bit analog to digital converter. Again listen, you can notice here for 1-bit analog the time frame is very wide here. For 2-bit it is less wide, and for 3-bit it is very small. The time frame is there. Higher the number of bit, better the conversion is accuracy. Means here the time frame or sample time lines we are taking there should be very close to each other or very high bit. So we have to use here. The higher the number of bits, better the conversion accuracy is achieved. Okay, so here the sampling. So what is sampling? Sampling, it is the process by which we are going to convert this analog signal into the digital one. Here you can see this original signal. So this is the original signal shown here by the dotted line, and we reconstructed it by means of the sampling. So for this sampling theorem states that if the highest frequency contained in the input signal is f of n, then input signal can be recorded without any distortion if the sampling rate is at least twice the input signal range per second. The sampling rate is known as Nist rate. Here you can see this is the original signal, and here we are going to take this sample period which is continuous over the signal, over the input signal line or original signal, and we are going to reconstruct this original signal, and here we get the sampled signal. Okay, so here we have the frequency of input signal and frequency of sampling. Both the terms are very important one. So here you can see this is the analog frequency. When this analog frequency is equals to 00 of the sample frequency, at that time we get the straight line. And you know that analog signals should not be straight, they are continuously varying because they are continuous signals, so it is not good one. So here you can see as per the Nyquist theorem, so the sampling frequency should be twice or greater than twice of the input frequency or original frequency, or which the frequency which we or the frequency of the signal which is to be reconstructed. So you can see when this analog frequency is 0.09 of the sampling rate, at that time we get the reconstructed sample like this. And when this analog frequency is 0.31 of the sampling data, at that time we get this sample like this here. When this analog frequency is equals to 0.95 of the sampling data, at that time you may say that this sampled data or sampled signal is quite similar to the original signal. So to get this sample signal as original signal, we should keep this sampling frequency greater than or equals to 2 times the original frequency. So here you can see that when this frequency is quite similar, we will get this quite similarities between the sample signal and the original signal. And when you increase the sample frequency more than twice of this original frequency of original signal, at that time we will get the sample signal which is acceptable one. Again listen me, sample frequency should be twice the input signal frequency, and it is still by the Nyquist theorem. Here are the another concept of the sampling, which is aliasing. So aliasing results into a different signal when reconstructed form. Here you can see the dotted line, it is the original signal, but the reconstruct and the continuous line, it is the reconstructed signal. You can say that this original signal and reconstructed signal are having very much different, and this defect or this phenomenon we called it as a aliasing, when this reconstructed signal is totally different from the actual signal. Just a minute. Okay. So why this aliasing effect occurs is, aliasing is caused when the signal is sampled at a frequency that is less than twice the frequency of signal being sampled. Here you can see this is the original signal, and the frequency of this original signal is very high as compared to the sampled frequency. So these two frequencies should be as per the Nyquist theorem. Here you can see, if this condition of the sample frequency should be greater than or equals to 2 times the input or original frequency of wavelength, if this condition is not satisfied, at that time this aliasing effect can be caused. You can see here aliasing is caused when the signal is sampled at frequency that is less than twice the frequency of signal being sampled. If you want to improve this, increase this frequency, this time sample should be reduced. We have to take the sample points at very less time, or multiple times we need to take this, so that this sample frequency should be greater than or equals to 2 times the input signal's frequency. Okay. Aliasing occurs when the signal is measured in an insufficient sampling rate. The sampling rate should be high. An original signal is reproduced at a wrong frequency. This phenomenon is called as aliasing. The sample and hold operation, this is a simple one. The sample and hold operation is used in analog to digital converter to stabilize the voltage while it is being converted to a digital value. Sample and hold operation consists of a voltage holding capacitor and a voltage follower. Here you can see it is the voltage follower, and this is the capacitor which keeps the which holds the voltage in that analog to digital converter. When switch is closed, here you can see when switch is closed, the output voltage is equals to the input voltage, and when the switch is open, the capacitor holds the voltage corresponds to the last sample value. So it is what happening while sample and hold circuit. What is happening whenever the switch is closed, at that time the input is recorded here, and the input signal is recorded in the form of the change in voltage here. But when this switch is open, i.e. no input is provided there, so at that time this capacitor keeps the voltage in that circuit constant, or it kept it as the last value it is recorded, or you can say it stabilizes the voltage while it is being converted to a digital value. Here you can see when the switch is open, means this switch is continuously going to be open and closed, because it is depends on the sampling rate. So when this switch is open, capacitor hold the value correspond to the last sample value, and we will convert this analog signal to the digital signal or binary signal there. Okay. So interfering sensors or actuators to data acquisition system. So here we are going to take example of this petrol nozzle. So you all are very familiar with this example of this petrol filling. You all of the listeners who are going to listen this lecture, all of you have experience of filling the petrol at petrol pump. So there what is happening, this you pay the worker there, and he fills the paid amount value petrol in our fuel tank of our bike or your car. So what is happening there, when you pay him money, he press the button on this keyboard there, and this IE he is sending a signal there. Then this signal is conditioned there, and it is sent to the computer by means of the binary values. Then computer what will do, computer inside this computer software, it shows this value on the display board. You can see, you know that when you pay, suppose you pay him 100 rupees, he press the button on this keyboard of this signal conditioning or this machine there. At that time the value press are then sent to the computer there, which then computer display this value on the screen, and also it store in this storage also. Then computer send this digital signal or these signals to the data acquisition hardware, where it reads this value, and then nozzle gets open. Here the nozzle is open by means of the actuator. So all this process is working on the conversion of this data, or either by signal conditioning. You can see here. बघा आपण जरा मराठीत घेऊ. इथे काय होतं, जेव्हा तुम्ही पेट्रोल पंपमध्ये जाता, पेट्रोल पंपवाल्याला तुम्ही पैसे देता, तर तो काय करतो, बटन तिथे प्रेस करतो. सपोज 200 रुपये दिले तर तो तिथे 200 हे प्रेस करतो. हा काय आहे, फिजिकल फिनॉमिनॉन. हा फिजिकल फिनॉमिनॉन काय होतो, सिंगल कंडिशनिंग जो सिग्नल कंडिशनिंग हा जो तिथे भाग आहे आपल्या सिस्टीमचा, तो त्या फिजिकल फिनॉमिनॉनला बायनरीमध्ये कन्वर्ट करतो आणि त्याला पाठवतो कम्प्युटरमध्ये. बरोबर. मग कम्प्युटर काय करतं, आपल्याला ते अमाऊंट डिस्प्ले करतं आणि तो डाटा स्टोअर करून घेतो, आणि परत काय करतो, ते बायनरी जे इन्फॉर्मेशन आहे ते ती परत सेंड करतो डाटा ॲक्विजिशन हार्डवेअरला. हार्डवेअरला गेल्यानंतर काय होतं, तुमचं हार्डवेअर म्हणजे काय आलं इथे, त्या वर्करच्या हातामध्ये असलेलं नॉझल, त्या नॉझलला तो काय करतो, ती इन्फॉर्मेशन पाठवून देतो. नॉझलला इन्फॉर्मेशन पाठवल्यानंतर काय होतं, तुमच्या नॉझल ओपन होतं आणि परत क्लोज होतं. तर हे काय आहे, ओपन अँड क्लोज, इट डिपेंड्स ऑन दी सिग्नल हिअर. हा सिग्नल जेवढा छोटा किंवा मोठा असेल तेवढ्या व्हॅल्यूपर्यंत तुमचं जे पेट्रोल पंपचं नॉझल आहे ते ओपन आणि क्लोज आहे होईल. हे ओपन आणि क्लोज हे आपण ज्याच्या सहाय्याने करतो त्या इन्स्ट्रुमेंटला आपण नाव दिलेलं असतं ॲक्च्युएटर. ओके. इथे बघा मेकॅनिकल सिस्टीम आहे पेट्रोल पंप. त्या मेकॅनिकल सिस्टीमवरती तुम्ही पैसे दिले, त्यांनी त्या वर्करने तिथे पुश केलं, म्हणजे त्यांनी पुश केलेल्या गोष्टी बटन्स जे आहेत ते सेन्सर्सनी सेन्स केले. नंतर इलेक्ट्रॉनिक सिस्टीमनी त्याला ॲम्प्लिफाय केलं, त्याचा डाटा ॲक्विजिशन केला, म्हणजे काय केलं आहे, तुम्ही तो डाटा संपादन केला. त्या डाटा संपादन करून तुम्ही त्याला बायनरीमध्ये कन्वर्ट केलं. बायनरीमध्ये कन्वर्ट केल्यानंतर आपण त्याला पाठवलं कंट्रोल सिस्टीममध्ये. कंट्रोल सिस्टीमने काय केलं, त्याला स्टडी केलं. त्याला स्टडी करून त्याला परत ॲक्वाइज केलं आहे, परत डाटा ॲक्विजिशन सिस्टीमला पाठवला. डाटा ॲक्विजिशन सिस्टीमने काय केलं, त्याला सिग्नल्समध्ये कन्वर्ट केलं आणि पाठवलं कुणाकडे, ॲक्च्युएटर्सकडे. ॲक्च्युएटर्सनी काय केलं, फिजिकल वर्क तिथे परफॉर्म केलं आहे, म्हणजे समथिंग ओपन अँड क्लोज इज working there. So this is the example of this interference of sensors and actuator to data acquisition system. Okay. So the steps in this data acquisition system I will explain in the next section. Thank you.